Aloha. Although quantitative research methodology enjoys widespread application, it is often misunderstood as being rooted in positivism or logical positivism. By associating quantitative research with outdated philosophical ideas, this misconception has fueled unnecessary disputes between qualitative and quantitative researchers. Such misconceptions may discourage students and scholars from embracing quantitative approaches, limiting their analytical toolkit. While I addressed this issue extensively in my book Philosophical Foundations of Quantitative Research Methodology, the myth persists, appearing repeatedly in textbooks. It is important to clarify the distinction between classical positivism, originated from France in the 19th century, and logical positivism, which emerged from the Vienna Circle, a group of European scholars active during the 1920s and 1930s. Classical positivism asserts that scientific inquiry must be based on empirical and tangible observation, rejecting abstract, theoretical constructs, and thus leading to an anti-realist and instrumentalist stance. Logical positivism, while similarly emphasizing empiricism, adds the verification principle, arguing that only statements verifiable by logic or direct evidence carry meaning. Both versions are complex, and this brief discussion cannot address all their nuances or their compatibility with modern quantitative methods. I will, however, focus on one essential point: the relationship between positivism and realism. At its core, positivism argues that knowledge is derived primarily from sensory experience and empirical observation. Statements that cannot be verified empirically are deemed meaningless. Positivism rejects metaphysics, viewing scientific theories not as representations of reality but as tools for organizing observations, what philosophers call instrumentalism. In contrast, realism posits that an objective reality exists independently of our perceptions and that scientific theories can uncover truths about this reality. Among the many versions of realism, such as naive realism, critical realism, and scientific realism asserts that successful scientific theories accurately describe both observable and unobservable phenomena, like atoms or quarks. This divergence over realism and anti-realism is reflected in the history of classical statistics. Karl Pearson, a major figure in the development of classical statistics, exemplifies a positivist perspective. In his book The Grammar of Science, Pearson argued that science should focus on describing observable facts, rather than seeking causal explanations. He dismissed metaphysical concepts and unobservable phenomena as irrelevant, treating theoretical constructs as tools for organizing sensory experiences. In contrast, R.A. Fisher, another central figure in classical statistics, took an approach that implicitly embraced scientific realism. Fisher revolutionized the logic of causal inference through his work on randomized experiments. Fisher's focus on distinguishing true causal effects from random variations reveals his underlying belief that causality is not just a semantic construct but a tangible aspect of the world, discoverable through scientific inquiry. Following Fisher, causal modeling has continued to evolve. Techniques such as factor analysis, structural equation modeling, tetrad path searching, and potential outcome modeling aim to uncover causal relationships, whether between latent constructs and observable variables or among multiple interconnected pathways. These advancements reflect an ongoing commitment to uncovering patterns that correspond to real-world mechanisms. The subject matter of causality is discussed in my book, Causal Inferences and Abductive Reasoning, between automated data mining and latent constructs. Basically, causal mechanism implies certain genuine relationships. However, the debate between realism and anti-realism in science is far from settled, and it is unlikely to reach a definitive resolution. Some scholars dismiss the idea of reality as a mere social construct. Yet in practice, most researchers behave as though realism holds true. To illustrate this, imagine a Star Trek episode where a malfunction in the warp engine would destroy the ship. In science fiction, these causal links are purely fictional. Warp engines and photon fluctuations exist only as imaginative constructs. If a real-life engineer treated these phenomena as real, it would be absurd. Similarly, in psychology, if depression and job performance were regarded as fictional entities, a researcher could at best describe an abstract correlation, arbitrarily named X and Y. Yet when scholars assign meaningful labels like depression or anxiety to theoretical constructs, they implicitly assume these concepts correspond to something real, however imperfectly. Quantitative research today spans diverse traditions, including the frequentist school, Bayesian methods, and modern data science approaches like machine learning. To suggest that all quantitative research is built on a singular philosophical foundation, positivism, is an oversimplification. Such a view ignores the rich intellectual diversity and interplay between competing research traditions. At the end of the day, I encourage you to maintain a healthy skepticism and examine the philosophical assumptions underpinning research methodologies. Avoid unquestioningly accepting popular myths and instead embrace the complexity and dynamism that make research such an exciting intellectual pursuit. Thank you for watching.